Hello, everyone. So while checking the people session on Canvas, I am finding that for group one, the ML project, which is like, I'm very proud with this group. You guys are extremely active and I'm joining their Discord channel. I see them working day and night and really they are doing great job. So this is the only group which is full, already having 7 out of 7 students and who already started really working. So now for group two, like I don't see that they're missing one student. I'm not sure if one other student is going to switch or it's solved. So we need one more student for group two. Once we're reaching the limits, we cannot add any students. So the last student who's going to choose is the one who's going to join this second group. And after this, everyone is going to be automatically like added to the third group. Despite I was like last time adding the announcement, I was mentioning that we will have project validation. I did everything, but I'm shocked that still for group 3, the deep learning one, only 4 out of 6 students are there. Means we are already missing like, let's say 4 students in our class are not there. I wish that they will be like joining as soon as possible because we really need to start working. Otherwise, for other group members, especially I'm talking about group 2 and 3, don't wait for everyone to join. As I told you last time, you just create your Discord channel, you add me as well, and you try to start working, okay? And it's really late. I'm just saying that it's really late and you guys need to start working as soon as possible. Okay, there will be lots of fun, but you guys just start. If you will keep delaying the project, then believe me, there will be a big mess, especially that you will feel there is no time, you will feel stress and you will feel pressure. This is what I don't want it to happen in my class. Okay, so it's time to start. Okay, this is what I can mention. Now what we did last time, okay, the thing that because of like this Monday, I told you I was sick and we didn't have class. In that class, we were supposed to have the ensemblist methods. Ensemblist methods are like we see in generative methods and we see like typical machine learning methods. We tried to create like 3 groups. This is the last one. And it contains like methods like decision trees, like XGBoost, things like this. So I don't see it fundamental for now, especially for groups 1 and 2 working on machine learning. They may need to implement these algorithms for the classification task they are like going to perform, but it's not urgent because the classification and algorithms are requested for the session of like 2nd December, so still time for that. Now we have an urgent need, and I was receiving your emails, guys. So an urgent need to explore neural networks. This is why I'm making now priority for exploring neural networks. I am going to start during this like session and the upcoming 2 sessions to explore things together, to make things clear so that the deep learning project can start reading and understanding the paper, because you need to know what are neural networks first, and you need at least to know what are CNNs, which are convolutional neural networks, in order to be able to understand the paper. So I'm going to give for now the priority for this, and next we can come back to the last set of methods, which is the ensemblist methods in machine learning. Okay, so for today, we are going to go through neural networks and introduction. We can discuss like if you have any questions. Next, starting from like next week, there will be only convolutional neural network, which is the tool needed for the 3rd group to explore that paper. So for all the groups, now machine learning, you have everything needed for now. So for all the groups, if I will keep like keep you working alone, I'm sure there will be some groups who are not yet even starting, so there will be a mess. This is why I'm deciding to have a follow-up meeting with you guys I am always available during my office hours if you need anything. Most of you know that. And I want to make like at the end of each class, 15 minutes at least to discuss your progress, what you did so far. So to start with, next class, we are going to have a follow-up with group 1 and group 2, means with the machine learning groups. I need to understand where you guys are standing that day. And if you have any problems, we need to discuss. So it will be like a quick meeting of 15 minutes. It's not a validation. I will not give any marks. I will be like not giving any decisions. So feel free and don't put any pressure. Just because of doing this, I'm sure that you guys will work. So I'm going to add an assignment, follow up like meeting with you guys, only machine learning group. I cannot do it with a deep learning class because still we are not exploring things. So after that, when I will be like teaching the convolutional neural network, they may have like few days, they can start exploring the paper. And 13th of November, we are going to have the follow-up meeting with the third group, which is the deep learning group. So I will understand if they're facing any problems. We can give tips how to read the research paper, because I can understand that for your first time, I'm not expecting that everything will be excellent. I'm here to guide you, and I'm really happy when I receive emails that you don't understand something. So because this is my role. Now, as you can see here, for November like 18, this is the project validation. You will ask me, you didn't say many times in the announcement it's going to be 11. So I can see the pressure, and I want to make things easy for you guys. I know that you are engaged with other like classes, you have other projects. So for now, and I also want to be fair with the deep learning like group. This is why I'm going to give you more time. So for the groups who are not yet even starting to start, and like this, we will be having our first validation on 18, because if I will keep it on 11 and groups are not even starting until today, I'm expecting a disaster. So I'm giving you time, and I wish I will really be proud of you guys, okay? I think like this, it's okay. Any questions regarding this part? Okay, after that, now once we will be like almost done with AI, machine learning, deep learning, we can explore more advanced deep learning like things, architectures or models. I know that deep learning, like machine learning, deserves a separate class, but we are going to try to cover things like the maximum we can do. If you will have the chance to have it in a separate class, you will see things with more details. I'm not expecting from you to like dive that much into details, just try to understand the concepts and all. So,
Sorry to interrupt. I just realized I did have a question. My bad. Did you say you were gonna post like a rubric or what you're looking for the validation?
Sorry, Zoya, I believe there is a problem. You guys are also not hearing well, right? So we cannot really hear you very well. I think it's from your...
Testing 1, 2, 3.
I mean, it sounds okay to me.
Sounds okay online.
Okay, I can put it in chat. Here, put it in chat.
From Jeremy. I wish it's not from our internet connection.
I think it's just an echo in this.
Yeah, there is
in this classroom.
echo. So anyone
Audio must be on 2 outputs somewhere.
No. Anyone is joining from his laptop? I'm not. Can you try to speak now, Zoya?
Okay, testing 1, 2, 3. I put it in chat as well.
Yeah. Okay, now I think it's better.
Oh, cool. All right, I can just ask then. I know a lot of our group members really wanted like a rubric or something that we could actually read through and like check off to make sure we're on the right track for the first validation. So do you like have one of those that we could use or?
Yes, sure. I will be providing like written instructions on like how the validation is going to be, which means how you are going to collect points. And during the validation, I'm expecting everyone to participate. So I'm making it late for this reason as well. And what else? So for now, I know it's still not the time to think about your final project presentation. Now it's your time to do your pre-processing. It's time to explore your data. This is why I don't want to make you think about presenting things, because it's the last day. So after, I believe, like the follow-up, I am expecting to give you what are like final deliverable like I'm expecting from you. Okay, so for now, keep working, because it's all about technical things. You are exploring your data set, you are doing pre-processing. I don't want to limit you. Like I would say, you will get 1 point if you will do like grayscale, if you'll do normalization, if you do. I want to explore all these things by yourself, and after that there will be for sure a reward. Like I don't want to like limit you with the details and instructions. I want to explore things with total freedom. After that, I am going to tell you, like for ML groups, how many slides I expect. Each student is like how much time, like 2 minutes, 3 minutes, and each one is like how I see it, like part. Something else is very important for group 1 and group 2. As we're going to do the follow-up meeting soon, and you guys will have more time. So the first part is not only about exploring your data set, like pre-processing and all. It's also about preparing your data to feed to the ML algorithm, which is going to be, you start working on that after like the first validation. So you will have time here, and what you will do is, I know some data sets don't need that much pre-processing, like MNIST, and it's already like a clean data, like DERM-T2M, the skin cancer one. So what you will also need is to extract the features. And I was mentioning that there is a set of like methods or descriptors to extract features from an image, which is the most important key points. So probably we will discuss after the follow-up meeting. And once I will see your progress on the data set, we can discuss about the SIFT, and I keep you working about that. So for the first validation, you will also present that. Like this, I see that it will be enough for all the group members to present. Some like will be talking about the 3-4 data sets. Maybe you'll be adding more data. Some will be all discussing like this feature extraction part. So I see it like it's going to be a rich presentation, and it may need more people to present. But I will be like providing that, and each time before the validation, I send an email or like with the announcement, I announce, and in the announcement, I tell you the instructions, like but make always sure that your calendar for these validations day, it's like you're not taken, okay? Because it's very important to be there, okay? So did I answer your question, Zoya?
Yeah, that really helped. Thanks.
Okay, great. Any other questions? Okay, so far what we did in the AI class, we started with AI, what is AI, and we seen that the evolution from like of each like type of logic until reaching the fuzzy logics. And also we seen that whatever AI in all the cases, it's like we are trying to create a program based on a set of rules, and this program, like let's say, behave like human, like can sense, reason, act, and adapt. In this context, you can see like the recent achievements, or what Elon Musk like was sharing 2 or 3 weeks back. So you see that robot, you see how we were in the start, like stick with that dog, and we're seeing it's such a huge thing, achievement, and how today things are completely changing. We are talking about like a huge progress in a short period of time. After that, we say from rules, from like defined rules, we are moving to the learning part, where we are introducing to our algorithms some learning thing like humans. We learn from experience, we learn from huge data, we learn from like what's happening around. So in machine learning, there is the word learning. In deep learning as well, there is the word learning. In the start, we tried to go through. I won't say we are covering machine learning. We went through machine learning, and you are also going to explore that in depth during the projects. If you will have a chance to get a machine learning class, I will also encourage you to do that. So at least we are understanding what is machine learning, which is not a simple concept, which has complicated algorithms, but at the end we try to simplify things as much as I can. So after machine learning, there is a subset which is deep learning. And also here we find the word learning, but the difference is from machine to deep. So we will see the transition now from machine learning to deep learning. This is what we will do today. So machine learning, we said, is algorithms whose performance improve as they are exposed to more data over time. And we see like KNN, K-means, there is more data and the algorithm is learning, okay? And now in deep learning, last time when we were talking about this, we said it's a subset of machine learning in which multi-layered neural networks learn from vast amount of data. So if you compare machine learning, deep learning, and this I will let you explore during your projects, and this is why I was mentioning for both ML groups, you are going to try to classify your same data with ML algorithms, yes, but in all cases using a CNN, which is a type of deep learning architecture, okay? So this will show you how when you are having more data, and I wish this is going to be approved with the experiments you're going to do, but the more data you have, probably the better performance you will have using CNN rather than using typical machine learning algorithm, okay? I will let you explore this and I will let the results approve this. However, some machine learning algorithms, they have their power, they have their advantages, and this is the output of the ML project, is to discuss the difference between all these things. For the deep learning project now, we are going to have a hands-on experience with the research, we are going to explore something new that may change your whole career plans. If you are planning to do research, it's going to teach you how to read a paper, how to develop and how to implement the paper, also how to see that there is no perfect paper, and how from a given paper we can think about the new ideas or make it better, or implement some perspectives, okay? So for deep learning now, if you guys remember this video, and I will always come back to this video. So this I made, there is no voice, but if you guys remember, this I made when I was not in person at UM Flint, and I was posting in the announcements. It was not me. I'm sorry, this is not me. It's a representation of mine. So it's the speech I was giving as input, and it's generated. So you can see me saying things that I didn't say. This is the same thing that in MIT, I was also checking one course when the professor was bringing at that time Obama, saying welcome to the deep learning class, and that video you can find it on YouTube as well. You are bringing someone and letting that someone say something he didn't say. So this you can do with AI, we said, but let's be now more precise. You can do this with deep learning, okay? So deep learning allows doing something like this. Not only this, deep learning allows doing many things, and today we are going to explore. If you have, like we did in the machine learning class, we're going to brainstorm. If you have some idea about apps, idea about, if I'm going to say deep learning, what does deep learning mean to you? So deep learning, what comes to your brain? Like we did last time, I'm going to give you a few papers. Online, you're going to share your thoughts with the chat, and I'm going to write that. We are going to discuss first what you guys already have or know about deep learning. And after this, we are going to clarify if there are some concepts which are not clear, if we can clarify things maybe. So this is what we will do before learning. We just need to check your background. So we will give more paper at the end. So try to think about at least one, okay. Okay. something that comes to your brain when we talk about deep learning. Okay, provide more papers. So, what is this deep learning? I'm sure that you heard about deep learning before, right? So whatever. Just write your name down so we can discuss the different ideas. Okay, let's check the chat now. Okay, no messages online. Okay, I give you time to think. Between.
You should be seeing online messages.
Okay, we received. Great. Try to make your answer short, okay? Okay, to explain, but try to keywords, brainstorm. So yeah. Okay. Never hesitate to share with me if sometimes you don't understand something. And don't expect, like, if you are, whenever you are participating, I'm expecting you're saying the most correct answer ever. So we are learning together, and I understand this. So even if you don't understand something, and I always ask, you understand? Am I answering your question? So even if you're asking the question for 10 times, for me, it's okay. Even if you don't understand, when I explain to you, never hesitate to say repeat again, because this is my job. So at the end, this is your chance to start the deep learning journey, whether you are going to love it or hate it. So don't keep your questions, and don't ask your questions, and feel shy from asking your questions or giving your ideas. Like, for example, now we have 5 students. I only receive answers from only 2. This is all the time happening from the online students. Never hesitate to send, okay, deep learning. Say I don't know it. Send a message, okay? Say anything, even if now I'm expecting some answers. I want to correct if there are any wrong, like, ideas about deep learning before starting. So this is very important. I'm not expecting you will say something which is accurate or excellent. So don't feel shy. It's your right, and you need to participate. It's like this you learn. So I encourage everyone to send message. What does it like mean for you? Even if you don't know, try to guess what is this deep learning, or any apps, anything. So anything related to this. Did you ever heard about this? So even if you didn't hear, try to think about something, brainstorming. It's very simple and there is no bad idea. So if you are having this idea, we're going just to discuss. So try to profit from this time. Enjoy this time. So we have more messages. Okay. What's wrong with Alicia?
Well, she gave an answer at the very top, and then we kept coming up with other answers, so she also was participating.
Okay, so she's not sending. Okay. Neural networks is all I know. Well, I didn't see your answer, but this is great. Okay. Which is correct as well. Okay. Here, rewards and punishments. Okay. So for Jimmy, your answers are the evolution and the second message, the reading why. These two messages are just one or separate?
Separate.
Okay.
You didn't like my reading while scuba diving joke?
I want to keep it secret. I cannot share the whole idea
Oh,
with
sorry.
everyone. Because they're still thinking. Okay, this is interesting, the last one. Okay, we are done with the online. This time we have more long answers than. Are you done, person? Or you need more papers? Just let me know. Need more papers? Are you done? Okay. Thank you. Okay, do you have a copy of this? Thank you. Wow. I think it's for you, right? Just to mention your name. Yes. more answers from data. Thank you. Wow. Any other answers online? Okay, that is it. So I think we are done with our okay. So thank you for your answers. And we are having a set of great answers. So I'm going to start randomly with the first one, very long answer from Jeremy. So how does the handwritten digit reader neural network deal with something that isn't a digit, like a backward tree or the letter H? Could it like have an 11th option, not a human? Okay, so Jeremy, can you explain this like idea?
Not a number is what I was thinking of. So you've got this neural network that's trained on 0 through 9. And then I'm curious about what a new piece of data like the letter H, as it goes through this neural network, it has to choose between, 0, 1, 2, all the way to 9. It has to land somewhere. And I was curious if there was any way for it to land on, nope, it doesn't match 0 through 9. So I just put it into this 11th category of not a digit, not a number.
Right, so this is a question from an expert of deep learning, but it's great to start like this. If it's up to me now while brainstorming, I may add just in one word, classification. Okay, so if you are saying that in deep learning, we are working on like classifying digits from 0 to 9, if I am giving two, like I have 0, 1, 2, 3, 4, 5, I need to write all of them, okay? 6, 7, 8, and 9. So if I have an input to the neural network, which is until now, what? An algorithm. I can expect like something like a classification algorithm, okay? So for this algorithm, now what if I give him a new data, which is H? Okay, so what this algorithm did? This algorithm is different. It has a particular structure. I can see here things related to the definition of deep learning. Like if we talk about deep learning, mainly we talk about NL. I see NL in like many answers, which is neural networks, okay? So when we talk about deep learning, there is a network of neurons, okay? So when we talk about neural networks, it's a model, okay? It's a particular type of architecture, but it can help us understand what is that about. So in this architecture, if we are talking about, we can define it given we have multiple layers, okay? So you can imagine if I say deep learning, it means an algorithm that could be used for the classification task. It can also be used for different tasks. We can come like to this point, but this algorithm is mainly composed of, like if we go into the architecture of deep learning now, there is a set of layers, and also there is a set of, so this is the architecture. So to answer your question, Jeremy, we need first to understand, given the like words we are brainstorming, what is deep learning? So we have the words related to architecture, okay? And we have layers, we have activation function from Ayub. So a neural network contains many layers and contains many activation functions. This is what we will see today. It is powerful. Okay, thank you, Dallas. So the power is coming from the nature of its architecture, which is, you are also talking about neural networks. And when we say deep learning, it's exactly neural networks with more layers. Thank you so much. It's deep because there are more layers, okay? So we will start today with a neural network having less layers. We will understand what is that. And after that, we will move towards more complicated or complex architectures that are having more layers, okay? And this is all related to the architecture, to the design, to the model itself. Now, this architecture, it takes as input data. So Dallas again is saying sorting through billions of data to find patterns that would be impossible for humans to find. So I may highlight the most important word, data, because this is the input, and this is mainly how it works, okay? So how it works is related to definitions, okay? So let's again go to neural networks, here is the type of architecture. How it works, it's like taking the input and the way it works here, okay? It takes data. It mainly, we know that deep learning is great when it has more data, okay? But in research, there are deep learning methods that's still performing well with less data, okay? But in general, there is no difference between these methods and machine learning. If I have less data, I have my machine learning algorithm. I can implement that. So this is for the input. Let's say this part is going to be related to definition. And let's say input. So here we have the input, which is our data. And overall, what is it, or what is it doing, and like this. Next, we can find some answers related to the applications, or let's say to the domain or field where we can see deep learning there. Okay, so one of the applications is this very interesting one of hand digits classification. And we'll come back to this point and we'll discuss what happens in the particular case or scenario that Jeremy is introducing. So we have here evolution and Jeremy again, natural selection of models algorithm. So you can explain this point?
Yeah, I've seen videos of people using deep learning to try and play this game called Trackmania. And what it'll do is it'll spawn like 25 instances of, whatever this thing goes through. And then the algorithms that do the best spawn more algorithms based on its strategies. And then they keep getting better and better in that way.
Which means here you are more into the application of deep learning in this scenario,
Yep.
or more into the mechanism of how they are using or employing deep learning and comparing and so on. So for this point, where you see it more?
It depends on if deep learning always uses what I described, or if it's a specific way of using it.
So it's a use case, right?
That's what it sounds more like, yeah.
So we can put it like a kind of application or a domain where you have seen deep learning, train it, and you see they're working more on making it performs better for a particular task, given a particular domain, right?
Sounds right.
Okay, so this is also an application. And then we have, playing video games, again from Jeremy. And you're saying up, down, accelerate, and also this is also an application where you see deep learning deployed or used. So in video games, you see that. In classification tasks, you see that. In natural selection and evolution, you see that. And I see Gautami is saying used in signal processing for better communication. So this is an excellent answer. Can you tell us more about this use case?
Well, for example, let's just say we have a group of people in stadium or somewhere, and the bandwidth will not be sufficient for the people. And by using this, like we can estimate the need of bandwidth, and we can allot the.
Great. So when you say we can estimate, means you're talking about prediction. Okay? Mainly deep learning is designed for classification tasks, also prediction tasks. Okay? We can see it, like more applications. Like for example, we'll discuss that later. Otherwise, now we have neural networks. Here is like particular like architecture, starting points. And then with multiple layers and hidden states. This is Zoe's answer, which is related to the architecture. Okay, so related to the architecture, we can have here another keyword. I didn't see before. I see layers, so it's a more abstract word. Here I see more details about layers. So Zoe can distinguish between hidden layers, and if we say hidden layers, means there are other types of layers that are not hidden, which are the input layer that Jeremy suggests given feeding as input the numbers 0, 1, 2, 3 until 9 chart digits, and the last layer, which is the output layer, which is going to perform your desired task. In his case, he wants to give him like the expected class, and we will discuss what if this class doesn't belong to the training set, which is, for example, it's the neural network is trained for like to recognize digits, okay? And you are giving age. So in this case, there will be no error. It's not like the network say, oh, sorry, I'm not trained for age. Let's suppose that you are training the neural network, and you know the MNIST data set we were showing before. I can show that now. It's like you have an image, which is pixels, and you have like 0, for example, written. Or let me say the number 4 is, excuse me, the number 4, and I will say why 4 is written. So the number 4 is written like this, for example. And it's fed to the network in a grayscale like representation. Now, what will happen if instead of this 4, I am giving age? The network is trained and it knows. And you can see that age, that the example that Jeremy is giving, is most similar to the number 4, because you can see like this, like you can find it here, this line. Okay, you can find horizontal one, which is this one for the age. You can find something, another line, if it's more, it's exactly this one. So there is, and when you are going to train your model about the number 4, it means you are give training data, which means multiple representation of 4, which means 4 written in different ways or from different people, because we don't write the 4 like the same way. The same person can write 4 each time with different like representation. So the more you are showing to your network, probably some people write it like H, the 4. So if we will be reasoning like probably 4 is similar to H, and if I will feed this image in the same like gray scale image, like encoding type, everything embedding is the same like this one, so I can expect that maybe my model has seen something similar. However, if you are planning to test your model given like alphabets and you're training on numbers, this is something which is not supposed to happen. It's exactly like you are having a kid or you are having a student and you are teaching this student deep learning, and in the exam, you are asking him about history, not related to deep learning, sure. So it means there is must be always some logic. If you are asking some task or giving some test data, the model must be trained. Otherwise, there are more advanced techniques like transfer learning, like you train your model on data and you keep that in memory and you expose to more data. It will also learn from other patterns and so on. So we will dive into this, but what I tell you, the model will not give you an error. It will give you a class. It could not be 4, it can give you 1 because you don't know, okay? And it's a black box. This is what we will discuss today. So this is a problem but the problem mainly if you do this, because you are not supposed to do this. Okay, I wish I'm answering your question.
Yeah, I think when you mentioned that you take
Okay.
this and then add more to it later, makes sense.
Great. It makes sense for us as humans, but you cannot trust a neural network that it's going to predict the age given the most similar number on which it's trained, because you don't know how it thinks. Okay, so let's talk about this later. I will keep this example in mind, the 4 and 8, and I will come back to this point. So now this is already we're putting as an application classification task of digits, for example. Now we have a very long answer from Arshita. So can you please read for us your answer so we can, yeah, or we can discuss, or you give me the main idea. Deep learning helps us to examine huge data sets, less time. Yeah, this is true. This is true. Because when you say that we are checking or dealing with huge data, before, if we do that without using deep learning, and you will see this is the difference between both ML and the deep learning project. Deep learning project would treat the data as raw data. You will take it as it is, and then the network is going to extract some features. For the ML project, you are first understanding your data, you're taking time for this. You are pre-processing that, you're taking time for that. You're going to manually extract features like the SIFT, for example, descriptor. And after that, you're going to feed to the classifier. So if we are doing that within the same block, this is really going to let us get more time or do the same thing with less time. And results are very accurate. We keep it to the experiments. But in general, deep learning is a very powerful tool, and the success that is having is because of the accurate results in most of the cases. Because sometimes the researchers only publish the accurate results, but behind the accurate results, there are 3-4 years of failure and wrong, bad results. Okay, so next. With machine learning, it is very complicated to determine results with a large data sets. That's great. Deep learning uses neural networks. That's great. There are different types of algorithms. One of them is CNN, and that's great. Deep learning is vastly used in different sectors. So you are covering the whole thing from the definition to the architecture to the use cases. So you are mentioning healthcare. And this is the context that the project is going to be better accurate output. So there are many applications with use deep learning. Neural networks use neurons. Yeah, that's great. To classify data. So this classification task we're talking about. And every neural network. Did you take any deep learning class before? So this is what you will see.
Yeah, I have took a class in my bachelor,
Great.
but yeah, not very deep into it, just a little.
Oh, so this is what we need. Okay, this is great. Every neural network at least has 3 layers. No? Okay. Let's have what they got. At least. Okay. Okay, that's great. So what Harshita is trying to do, she's covering the whole thing. So we will put it in the definition part, which is the whole thing, architecture, domains, and everything possible. Okay. So next we have deep learning mimicking human neurology, memory, learning, reinforcement. This is from Zoya. So Zoya here is talking about the architecture. So from where it's coming, the idea of deep learning or neural networks, this is what we will see. And this is also related to definition. And here, reading while this is Jeremy's application. So you can tell us more about this app. It's really interesting app. Yeah.
You're learning while you're scuba diving, so it's deep learning.
Yes, that's great. So this is an application. And next we have, I think I'm covering all of them. Yeah, this is rewards and punishments. Again, from Jeremy, rewards and punishments. Here I see it on how the architecture is working. In particular, I don't know if you're talking about the training process or about a particular architecture or deep like reinforcement learning.
I don't either.
Oh, it can fit in both because during the train, if you have some negative value, there will be someone stopping you. Non-linearity, and we can see it like that. So it will not allow you to propagate. And I see it also in reinforcement learning. Like if you are doing good, there is a reward. If there is some mistakes, then there is punishment. So in all cases, within the architecture. So what we find now is that at the end, we are converging towards how many like groups? Groups related to the definition of deep learning. And I think we are good now. We are understanding what is deep learning. And here I'm dividing the answer of Gaussami into two. I find a very interesting one here, which saying has multiple layers to understand complex patterns. So this is related on how it works and to the architecture. Okay. So this is first part or group or cluster of definition. Next, we have like architecture related ideas. And we have at the end our knowledge of some interesting apps or application domains. And I have this answer from Alicia, which is NN is all I know. So this I wish you all say after the deep learning class. So the main point is to come to this knowledge. Okay, any questions now based on this discussion? No, it's clear. A little bit, the ideas are clear. Any questions online? Okay, then that's great. What we have now, we need to go through these deep learning ideas in depth. Application domains is not only like related to classification tasks. In classification tasks, you have beyond the classification of digits or characters here that Jeremy is mentioning. This is the example of how number 2, number 1, number 0 are written, and this is the MNIST data set. There is also face recognition, which is a classification task, and object detection as well. You have also the medical image detection, like whether MRI, skin cancer, or whatever your data or domain. You have it also in like voice assistant, the example that we started with. Whether me or like Obama, someone is saying something they didn't ever say. And the weather forecasting, you have it also in GPT models, in LLMs, you have it in stock price like prediction, in music generation, and you can really regenerate nice pieces of art. I can also go to this example of generating art. You can generate like image data, 3 object, elements. You can have like face attribute manipulation. Deep learning is also used for image to image conversion, things that we are seeing at trends today, like we are using everywhere. Like you have an image, and from this you generate the face or the hair mesh and the 3D avatar as at the end. You can use it in image compression. You can use it also in dimensional reduction. And in this case, we talk about the ACP, for example. If you remember, we didn't see the ACP, which is a very important PCA. PCA is the principal analysis component. It's a very important machine learning like algorithm. And the idea from this algorithm is that given your data, you are going to see or visually present it in the best, like, let's say, plane or given the best access or X or the best point of view. Okay, so this is going to be given huge massive data to plot it or represent it in like a reduced like domain. Okay, so the idea of deep learning is also similar. You have your input, which is a huge image of a huge size, and through the layers, and we are talking about layers, you are reducing the dimensions until, for example, from like this data set of the handwritten, it's 28 by 28 pixels, okay? at the end, from 28 multiplied by 28, you are going to converge to how many classes? 10. Okay, so there is a reduction of dimensions. It could be also used for fraud detection and so on. What is it now in depth? We think that AI is something which is not new, which is there since like 1950s, and it's just like this is where the early AI steers, like exactly starts there. After that, in 1980, ML started to occur, and we find the machine learning begin not only to show, and we find research papers on that and people talking on that, but it's becoming like blooming and taking more space. Everyone is mainly using ML in their research. And now starting from 2010, most of the people are like changing or like opting for deep learning. And deep learning here, breakthroughs drive AI boom. Okay, so what we have, what is this deep learning that is now taking everything? If you see AI now, most of the focus is deep learning. And most of the interesting apps you see now, we are moving from boring apps, limited apps, towards what Jeremy is citing and what we are talking about. It's really interesting apps. It's all thanks to the deep learning, and starts with deep learning, like from deep learning to LLMs, from deep learning to such a great application. It's not a joke. Okay, so what is this deep learning? Okay, we can see there is a data like a huge field AI, subfield ML, and subfield deep learning. So whoever is going to ask you about deep learning, this is a definition that I didn't see. It's a subfield of machine learning, which is itself a subfield of AI. And this is the definition of deep learning. You will tell me layers, this is like related to the architecture. You will tell me about application domains, this is particular use cases. And here in the definition, I see, okay, great job done. But the fact that it's a subset from machine learning, which is subset from deep learning, I didn't see. And this is what you need to learn today. If next time I will say we brainstorm about deep learning, what is it deep learning? So you will say it's a subset of machine learning, which itself is a subset of AI. Okay? Okay, and this subset, what makes it different? So Zoe is coming to this point and saying, mimicking human neurology. By saying this, we are talking about this subset imitates the way humans gain certain types of knowledge. And when we say gain certain types of knowledge, I have seen this through your answers. So when you talk, like Harshita and someone else was talking about patterns, also Dallas, okay? So when you talk about that, patterns are like some way or somehow we are learning this number 4, for example, how it's presented, what features are letting my network learn or my like algorithm learn that this is number 4. These are main features, this is knowledge, okay? And next, now when we talk about machine learning, I see an example like multiple layers. Okay, so when we talk about multiple layers, this is a particular type or the basic like architecture of neural networks. I see neural networks so frequently. There are a multiple layer perceptron. So we talk about perceptrons. There is the autoencoders. It's a very famous architecture. There is the generative adversarial networks, the GANs. They are also very famous. They could be used for data augmentation and many tasks. We find the recurrent neural networks like LSTM mainly, and the convolutional neural networks, also CNN answer I have seen so far, and we'll discuss this in details. But when we talk about machine learning, we talk about reinforcement learning, we talk, and it's connected. You see that we cannot say that reinforcement learning is only related to deep learning. No, it also is part of machine learning because neural networks themselves are a subset of this, okay? So we have the ensemble methods that we will see after deep learning part. There is a classical learning where there is a supervised and supervised learning. And for the supervised, we went through classification, KNN, SVM, decision trees, and so on. The regression tasks like linear regression, basically, and the unsupervised learning covers clustering, making groups. We've seen so far the k-means, The DB scan is another famous one. We seen actually beyond k-means, what we seen for clustering, the Gaussian mixture, the JMM. For the unsupervised learning, there is also the pattern search, another field, and the dimension reduction I was talking so far. There is a PCA, and there is like LDA. There is so. You listen to me talking about all this. You know how it needs years to learn all this. So don't think that the AI class is too much complicated. It's not at all. This is only one like AI class. This is your start probably. So you can expect having, I had a whole class only for studying PCA. Okay, I remember like whenever I'm coming to the class, we're only studying PCA for the whole semester during my master classes. So believe me, each of these algorithms, as a researcher, you can give 3 years of your life. So it's not something simple. At the end, we can make it simple, try to go through these concepts, and this is the main concept, or the purpose from this class. Okay, now machine learning is something that we already covered when we were talking about the evolution from AI to the learning, from rules to the concept of learning. And when we talk about learning here, or machine learning, it consists in programming a machine so that it learns to perform tasks by studying examples representing them. And when I say examples, it means I'm talking about from the real life. It is examples are presented to the model like data, okay? So the data could be shown, as you can see in this graph behind or here. So my data points are here. These are my examples. The machine learning model is something like this. Okay, this is a line. This is going to like give me, this is a regression problem. I need to present this with given one model. So this model is having some parameters. If may I move this value of A or B, I will have a different model, okay? So it's like I'm playing with these parameters in order to fit my model or optimize like these parameters. This is my main purpose. So when we talk about machine learning, we talk about optimization, which is a very huge, like famous problem in AI, in machine learning. And the idea, if you can see here, initially these parameters or like A and B could be randomly initialized. And after that, I keep like making it better, okay? And what does it mean, make it better? It means we were discussing that I measure the performance so that this algorithm is having the minimum error. And one way to compute the error, it's the MSE, which is the mean square error. Here we represent it when it's far, this like line. We have a very huge like value of the error, and then we are reducing until somehow we are missing the excellent point or the best point. So we understand that the best point is this one, where like we have the minimum distance between this like line and the data points. So for this, we program an optimization algorithm. This is what I was discussing in the machine, which will test the different values of A and B until obtaining the combination which minimizes the distance between the model and the points. So ML is to develop a model using an optimization algorithm, which is very important, and it's like giving a huge impact on your algorithm. So you are like implementing a CNN or implementing a KNN, or the optimization algorithm is very important. It means how you are measuring your error and how you are selecting the minimum error. So this is important to minimize the error between the model and our data. Now, if we will compare, like this is clear from both projects. The first project, which is the machine learning projects, needs some manual work. Okay, given the input, I given them the data set. Like they will do the efforts, they will do manual work in order to extract features. For the deep learning project, and this is the main difference, they will not do any feature extraction. They will feed the data as it is. And when we talk about feeding data as it is, means we're talking about raw data. Raw data, it means that I'm not extracting any feature. It's the data the way it is. I'm going to feed it to the deep learning. So here what we have, the feature extraction is like performed by an expert, by a human, And then there is the classification algorithm, which is defined and which is going to learn from these features. However, here we have both feature extraction and classification together in one block, and this is the difference between machine learning and deep learning. You can expect such simple questions in the exam, like what is the difference between ML and deep learning, and I want this answer because this is the exact answer. One, like there is a difference between extracting feature and classification, and one combines both within the same block, which is the algorithm. And at the end, we have, for example, if it's a classification task, our desired output, for example. Why now? Or we will ask the why later, or let's ask it now. Okay, this is the curve given this amount of data, and this is the performance. Now, deep learning is outperforming machine learning. This is clear, and we were already mentioning this, you know this. Now, why it's now today we are coming to deep learning? Why not before?
It's kind of a
Yes.
subset. Oh, sorry, go ahead.
Yes. So it's 3 points. I'm expecting 3 yes. So there are only 2 yes. Which one is missing? The first thing is the hardware and software. These are the 2 like yeses I'm hearing. So the hardware is that today we have really like great computational power. The second thing is the software. Now, if I'm talking, I will show you at the end, or why to wait to the end. I will show you right now a set of like IDEs that we can use, or frameworks that we can use for implementing deep learning. So you can see that there is huge like availability of software that is going to allow you to implement applications or execute algorithms that are designed for deep learning. So mainly we are going to work with Keras and TensorFlow, but it's not the only. There is PyTorch, there is also Caffe, there is like many other like frameworks. Now, this availability of software is making deep learning like bloom today in particular. There is something else, which is the big data, which is very important. You say deep, it means it needs more data. So I was supposed to hear this. Deep learning is not only hardware, software, it's also related to deep and to bigger data sets. And we talk about larger data sets and easy collection, because if you see how like we're dealing, there are like from web, from social media, taking picture today is everyone's memory is like gone. So we have more data, okay? And the thing is that the first AI neuron has been like introduced in 1943. It's not something new. When the perceptron has been invented is 54. And then the multi-layer perceptron is 86. And then the CNN like 90s. Then we talk about the LSTM and RNNs in 97. So you see all these dates, between each one there is like at least 10 to 30 years, which means it took too much time to move from one milestone, I would say, to the other. Because of these problems, now we have hardware, we have like all possible available resources. Since 2012, there is an exponential growth of deep learning algorithms. And this is thanks to the ImageNet competition, that whenever you are talking about deep learning, you must talk about this. This ImageNet competition came like to break the thoughts, like what you think about deep learning. It cannot do anything because we didn't have the resources, we didn't have data and all. And then there was this competition. Most of the people were using machine learning, were using AI rules and so on. And some like people were using deep learning. This group was winning. From that day, everyone is mainly like motivated and encouraged by this. We talked in 2014 about the GANs, and then 2022 about the ChatGPT, and now it's becoming super quick. So 2 weeks back, we can remember what's happening, Elon Musk and all. So now we will go quickly through the first artificial neuron. It was invented by these 2 famous scientists, Warren McIntosh and Walter Pitts. These 2 were like inspired, like Zoya was mentioning, from the human neuron in order to come up with this artificial neuron. So the human neuron, I don't know if you have any backgrounds about this or we need to explain. So when I touch something which is extremely hot, I need to take my hands like this. So how my brain is taking this decision, how it's happening, we will limit this to one neuron. So I am touching means I'm feeling, there is sense. So these are the dendrites, which are the neurons, like receives its input, which is if it's hot, if it's cold, what degree, and so on, thanks to this like particular structure, which is called dendrites. Now I'm receiving, this is my input. Now this neuron is going to analyze this. If it's that much cold, hot, sorry, I need to take my hands. If it's okay, then I will keep my hands. There's no problem. So who is going to analyze this? It's the cell body that you find here. So this cell body, after being like weighted by the strength of their respective connections, the connections are coming from these dendrites and all these inputs, and each one is having like strength, which is that much hot, that much cold, the intensity, and so on. This like cell body is going to sum all this together, and so we are like taking all this information together. And after that, after summing all this together, the information is going to go through what? Through something we call axon, okay? And this is like this sum is then transformed into a new signal that is propagated along the cell's axon and sent off to other neurons. So there is a communication. How it's sent? Thanks to the synaptic terminal. So the thing is that if I am going to assimilate this or model this, and when we talk about modelization, I was bringing that share last time. I said how to represent this to the computer, and we were discussing different ways. Now this how to represent my dendrites. These I can like present like inputs at the end. These inputs, they have strengths or weights, and then there is something which is the cell body. It's going to sum everything together. So this is a function that's doing the sum and also share or propagate or transform, and at the end I'm finding my output. So it works like this. Now I started modeling things. So this paper of Warren McLeish and Walter Pitts is coming 1943, which is shocking, which is like saying that neural events and the relations among them can be treated by means of propositional logic, which is now modeling this like neuron towards a function. So we are starting modeling things. Now, the first artificial neuron is expressed. I have my inputs. If we will talk now with math, the language of math, what we have. The inputs are the set of x's. The weights, these are the w's. And then my main function, which is going to sum everything after all, it's a mathematical function, which is going to take the inputs, which are weighted, have different strengths. So this function is f. It's mainly well known as the sum of products, which means it's going to like give the value for each input multiplied by its like weight. So it's W1 times X1 plus W2 times X2 plus W3 times X3. And this is called the aggregation function. After that, now we have this value and there is the output, which is Y. This output is known as activation. And we've seen so far activation function. Until now, we are not at that level, but the activation is to decide whether this signal is going to propagate. It worth means, for example, it is 1. F is more than 0, it's positive. So this Y will take 1. Otherwise, if it's less than 0, then this Y will take 0. And that is it. So until here, the first neuron, just a modelization. It's a way to represent this like this neuron from the biology sector towards a mathematical function, okay? And this is called the threshold logic unit. There is no learning, there is no connections, just a simple neuron, a function, takes input and gives an output, nothing more than this. Now, in the reality, if you zoom on the human neurology, what you will find, you will find more neurons, you will find more connections. So we talk about multiple neurons. So here we talk about the perceptron first. Before like connecting the neurons to each other, there is the idea of perceptron, which is invented like 1955 by Frank Rosenblatt. And the idea here is the same. We have the same model. We have our inputs, the x's. I have my function which is going to perform the aggregation and my output. The only difference, and I can ask you about the difference between like artificial neuron and perceptron. An artificial neuron, just the model, okay? The perceptron is when you are introducing the learning algorithm, okay? Which means I am not going to consider one W and like one weights for each input, W1 and W2. I would consider multiple, and from that I'm going to learn, okay? So this is the idea. So you have this function over like through the time, okay? So this is the learning process. When we talk about learning process, to make things simple, and I've seen this like one post, how neural networks work. It's very simple. I know a guy who knows a guy, because these guys are connected, and now we will use the knowledge, and this is the learning from each one. So it's simple. I know a guy who knows a guy, but I wish it's as simple as this, because there is a lot of math behind. We start with the theory, which is the Hebb famous theory. This Hebb theory, it says when two biological neurons are jointly excited, then they strengthen their synaptic link. So, which means I have these neurons. So these two neurons, there is a connection between these two, you see? So if now we zoom, if this one is like excited, and which means it's going to affect this one, which is could be also probably excited. And this is the Hebb theory. There is an influence from an excited neuron if it is like connected to another one, okay? And this like reinforce the synaptic link. Now, this perceptron now, we said it introduces the idea of like learning. And when we talk about learning, we talk about I'm going to check my output. If it's correct, then that's okay. If not, I am going to update my knowledge, okay? I know someone who knows someone who can fix this, okay? This is the idea. Now, train an artificial neuron on reference data, which means you're going to give more access, which is lablet data, and you know the output, the expected output, so that it reinforces its parameters W. The final like goal is to find the optimal W's here, that if you will give a new data, it's going to predict the Y correctly, okay? So this is the training process each time, so during the time. And what we will do here, the input X is activated at the same time as the output Y present in this data. So the idea is we are going to learn from these X's and Y's, which is our supervised data, in order to fix or converge to the best W1 and also W2 parameters, okay? This is the combination. The idea now is like how we are going to learn. This is the learning process. So we talk about learning process, we need to define that with a mathematical equation. This is like, we have the weights, which is our W, like W1 or W2. And this has the current value of W. And you are going to add to that a small constant, which is called learning rate, which is an hyperparameter you can tune, multiplied by the difference between the reference output, which is you are giving the real Y, the real level or class, minus the output that the neuron is computing here, because it's not going to find you exactly this in the start. It's going to keep learning and the conversion. So this difference multiplied by this small constant, so you multiply with like that input X. And like this, you keep updating the weights until somehow it converges. So we do not need to update anymore. No, what we have, this is an example, like, or for example, I have my X training data is Y, X1, X2 is 0, and at the end, my computed value is 0 at the time that I expect it to be 1, okay? the training data it's having as label 1. So how to compute this? The true label, which is 1, divided or minus the actual computed by the network or the neuron, the perceptron here, 0. So 1 minus 0 is going to give you 1, which is multiplied by alpha, it will keep only alpha, multiplied by x. So here your weight is going to be the actual weight. Add to that some alpha scalar x. And now, if now in the other scenario, you are going to have, you consider your x2, which is equal to 0. So what you have here, if your x is going to take the value 1, so you have w plus alpha, this is w1. If your x is taking the value of x2, which is 0, if you would multiply 0 with alpha, you will find nothing. Then for w2, it's w2. There is no update for this weight. Okay, you understand the concept? Is it clear for everyone? Great.
Yep.
Now,
And
this,
just to let you know, we are over time.
yeah. Just 1 minute. I just want to finish this, and so next time we're going to start something new. So now what we will do, we need to update or reinforce this W1 and W2. We are not going to do anything, okay? So next time we'll go from the idea of learning or learning algorithm within one single artificial neuron, which gives the idea of perceptron, towards the multi-layer perceptron, which is a connection between multiple, like multiple perceptrons. Okay, so we are done for today, and if you have any questions, just let me know. Otherwise, it's okay. Okay, see you next time. That is it.